Good morning, students. I am Navdeep Dhaliwal, faculty of Arya College of Engineering and IT, Electronics and Communication Department. Today, we will discuss about frequency modulated continuous wave radar system. So, these are my session outlines. First, we will discuss about limitations of continuous wave radar system, and then frequency time relationship in frequency modulated continuous wave radar system, and then block diagram of Fmcw radar system, and then working of Fmcw radar system, and at the end we will discuss about some important features of Fmcw radar system. So in continuous wave radar system there are some limitations. These are: it measures only the speed of target. It is not able to measure the distance between radar and target. So to overcome those problems, FMCW radar system is introduced. So FMCW radar system is a radar which transmits continuous wave signal and also changes its operating frequency during the measurement is known as FMCW radar, or we can say frequency modulated continuous wave radar system. It is also known as FMCW Doppler radar. It measures speed of target as well as distance of the target from the radar. This is main advantage of FMCW radar. Now let us see some graphical analysis of FMCW radar. So in FMCW radar, a signal is transmitted which increases or decreases in frequency periodically. The transmitter frequency is changed as a function of time in a known manner. Assume that the transmitter frequency increases linearly with time as shown by the solid line in figure. If there is a reflecting object at a distance r, an echo signal will return after a time t is equal to 2r divided by c, and the dashed line in the figure represents the echo signal. If the echo signal is heterodyned with a portion of the transmitter signal in a non-linear element such as diode, a beat note Fb will be produced. If there is no Doppler frequency shift, the beat note is a measure of the target's range, and that is Fb is equal to Fr, where Fr is the beat frequency due to the target range. If rate of change of the carrier frequency is f node, then the beat frequency is Fr is equal to f node t, or we can say 2r divided by c multiplied by f node. In any practical continuous wave radar, the frequency cannot be continuously changed in one direction only. Only periodically in the modulation is necessary, as in the triangular frequency modulation waveform as shown in figure. In modulation need not necessarily be triangular, it can be sawtooth, sinusoidal, or some other shape. The resulting beat frequency as a function of time is shown in figure. So triangular modulation, the beat note is of constant frequency expect at the turnaround region. If frequency is modulated at rate Fm over a range del f, the beat frequency is Fr is equal to 2r divided by c multiplied by 2 Fm, and we can say del f is equal to 4r fm del f divided by c. So thus the measurement of the beat frequency determines the range r. A block diagram illustrating the principle of the Fmcw radar is shown in figure. A portion of the transmitter signal acts as the reference signal required to produce the beat frequency. It is introduced directly into the receiver via a cable or other direct connection. Ideally, the isolation between transmitting and receiving antenna is made sufficiently large so as to reduce to a negligible level the transmitter leakage signal which arrives at the receiver via the coupling between antenna. The beat frequency is amplified and limited to remove any amplitude fluctuations. The frequency of the amplitude limited beat note is measured with a cycle counting frequency meter calibrated in distance. So here modulator used to modulate transmitter signal, and then modulated signal is sent to FM transmitter, and output of the FM modulator is the sum of two signals, and at the receiver section receiver antenna will receive a signal that could be increase in frequency or decrease in frequency. And the role of mixer is either its output is sum or difference, and whatever signal is generated by mixer, that is given to the amplifier, and amplifier will amplifies the signal and given to the limiter circuit. And the role of limiter circuit, it is bypass the limited amplitude and limited frequency signal, and after bypass it is given to the frequency counter, and the frequency counter will measure frequency in certain wavelength, and after that signal is given to the indicator, and final result is shown by the indicator. So finally we can find the difference between the frequencies, and it will helps to measure the precise range. Note, in FMCW radar, frequency changed as a function of time in a known manner. So there are some important features of FMCW radar. Is able to measure very small range and ability to measure simultaneously target and its relative velocity, and it has high accuracy of range measurement.